Purpose of this video is to simplify pointers. The initial code is extremely simple. X and Y, you add them, you print them. Now let's consider the next variant of the same thing. You create two pointer variables, and these pointer variables are supposed to point to X and Y. Here, line number 12 and 13, those pointer variables are made to point to X and Y. Then you ask the user to enter it and you add it. So now let's say this code slightly confuses you. So I have this suggestion for you that you simply execute each line in your mind, drawing the picture on a piece of paper. So let's say line number 6 happens. You basically have p underscore x, which is a variable. Pointers are simply variables. They store address of something. When line number 6 happens, you create a variable with some garbage value. We don't know what the value is because at line number 6 we never initialized it. Line number 7 we are creating p underscore y, again with some garbage value. Line number 9 and 10 we are creating x and y, which are integer variables. Line number 12 we are saying p underscore x is equal to x. What it means is that this pointer is going to point to x. Let's say this x is stored at 0x100. So the concept is that p underscore x as a integral value, pointer is after all an address. P underscore x, the value of p underscore x is this memory address where x is stored. So this is what it means when we say p underscore x points to x. What it means is that the value of p underscore x is the address of x, the place where x is stored in memory. So p underscore y also points to y. So now this is my picture, and then when you say scanf into p underscore x, you are really basically saying read at this address. So the value 10, if I enter value 10, it will get entered here. If I enter value 20, it will get entered here. And let's see the next one, which uses dynamic memory allocation. So I allocate memory. So assume it is malloc size of int. Read it like that. We are reading into it and then we are adding. I will start drawing the picture. So line number 6, we get p underscore x. We create a variable and garbage. P underscore y, line number 7 garbage. Line number 9, what we are doing is we are allocating a memory. We allocate a int worth of memory and we make this pointer point like this. This memory is coming from heap because we are doing malloc. Earlier when we were pointing p underscore x to another x statically allocated, that's another x was coming from stack. But now we are taking the storage from heap. We take another storage from heap for y, and then subsequent code is the same. You are reading two integers, then you add them and you print them. So this is the picture. Let's now see double pointers. Double pointer is nothing but a pointer to a pointer. Let's see the code first before we draw the picture. We have these single variables, single pointers. We have these double pointer variables. These double pointer have to point to the single pointer. Okay, so I am saying pp, that means pointer to pointer. Double pointer x points to p underscore x. That means it stores the memory location where p underscore x is stored. And then I allocate memory. When we read x and y, we earlier said p underscore x. What is p underscore x? If we say star pp underscore x, that is p underscore x, because pp underscore x is pointing to p underscore x. So when I say star pp underscore x, this is same as p underscore x. Okay, and this expression you can understand as star p underscore x, which will be x. Let's try to draw a picture. P underscore x, p underscore y, pointer variables. Now another pp underscore x, which is a pointer to p underscore x. So that means I can pictorially represent it like this, that pp underscore x is pointing here, and pp underscore y in very similar manner is pointing to y. Line number 12 and 13, you are allocating from heap using malloc, and p underscore x is pointing to one storage. same for y. Then you read values. When you do scanf, basically you want this address, that means the value of p underscore x, that means star pp underscore x. So I am not really covering pointers, arrays, double pointers in this short video. I will create more videos. We will see array versus pointers. We will see array of pointers, pointer to array, double pointer. This short tutorial is only intended to simplify pointers and give you an approach that you can understand them in a clear manner. Let's see little more code. Just analyze this code. Is it correct or not? So if you think a little, this code is likely to crash. It is likely to give segmentation fault because we are writing these characters at address 0. Again, the same approach of drawing picture. So what is happening? PTR is a variable and right now the value is 0. 0 means it is pointing to the absolute 0 byte. Okay. And hello world, you can understand hello world as a sequence of characters. So there are 12 bytes if you count. So these are copied byte by byte at this address. At which address? At address 0. Is address 0 valid? Is PTR pointing to some heap allocated or static allocated valid segment? No. It's pointing to address 0. We write at address 0, likely to crash. Let's see further. First solution is you please allocate memory to store it. You copy it, you use it, and ultimately you have to free. Let's see pictorially what's happening now. PTR line number 9 creates PTR which is null. Line number 11 creates malloc and stores that 200 bytes, and here it stores. Now we have legitimate thing, and hello world is a small 12 byte array of characters. In a way you are copying it byte by byte here, and it is very legitimate. You have 200 bytes, you are copying in the initial 12 bytes, no error. Another solution is you can avoid malloc. You can make it into a statically allocated array which comes from the stack segment, the function frame in the stack segment. So you are having something like this. You have PTR which is actually an array, and then you have this hello world 12 bytes, and you are copying byte by byte. It will be all fine. So what I am suggesting in this quick video is that analyze them in a pictorial way. Get the picture clear in your mind, and to get the picture clear in the mind, draw pictures on paper, and then things will be clear. I'll be creating more videos to demystify pointer versus arrays, what happens when we pass array to functions, how they decay to a pointer, array of pointers, pointer to array, double pointers. So these are not complex things. People are scared of them just because they are unable to think in a pictorial simple way.